Hello everyone. So in our last classes we talked about set theory, its representation and different special sets. Today we'll first start with the theory portion, different types of a set. Let us note down. So when we talk about different varieties of a set, the first we can talk about is a null set or an empty set or a void set. When I talk about an empty set, what will it mean? A set which does not have any element. For example, if I say set of class 12 student attending the class right now, there cannot be any student of class 12 who is attending right now. Yes or no? Agree?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Any other example that we can think of for a null set? Uh, Set of months of a year that has 40 days. Set of natural numbers between 2 and 3. So all these criteria are such which will not be satisfied by any of the elements. So all of these categories, all of these characteristics will result in an empty set or a null set or an void set. Similarly, I can have a set which has only one element. That will be a singleton set. Set of whole number less than 1, only 0. Set of teacher present in the class right now and the only one. Set of months in a year which is exactly 28 days, February. So any criteria which results in only one element is known as a singleton set. Done. Then we have finite and infinite set. Finite set and infinite set is basically segregated on the basis of countability. So if I'm counting the element and that counting comes to an end sometime in the future, it will end. It may end right away or it will end sometime later, right? But it will end. Then it's a finite set. And if the counting is not going to end under any circumstance, it's an infinite set. So if I'm saying a finite set of people living in Northeast, set of the population of India, all these is very easily available in Google, right? So all these are counted, census basically, right? So it can be counted, requires a lot of work, lot of money, lot of labor, workforce, but can be done. But if I want to go and count the set of all the stars in the galaxy, it's still counting. It's not going to end, right? So that becomes an infinite. All the natural numbers, it's never going to end. Even if you say 1 crore, I'll add one more, 1 crore 1. If you say 10 crore, I'll again add one more to it. So it is always an infinite set. Even all the special sets are infinite sets. Natural, whole, integers, they are never going to end. There is no limit to it. So all of them are going to be infinite. So when we are talking about types of sets, we talk about four. First, null set, empty set or a void set. A set which does not have any element. Second, singleton set, a set which has only one element. Third, finite, where the counting is going to end. Fourth, infinite, where the counting is never going to end. Yes? Let's quickly note down these theory points. Types of sets. First, null set, empty set or a void set. A set with no element. Now this is one of the most important one out of all the law. It is denoted by it is denoted by either an empty bracket. As soon as you write anything inside a bracket, it becomes an element. Even if you write my name inside a bracket, I'll become an element. You write 0 inside a bracket, 0 becomes an element. You can't write anything within the bracket, right? Or it is denoted by pi. Sorry. It is denoted by pi. No, pi is not a bracket. Pi is the symbol for the entire thing. It's a name. Like we use n now, we don't write that in a bracket. Similarly, we don't write pi also within a bracket. Pi is the symbol for the entire bracket itself. Clear? So, for example, set of natural number smaller than 1, less than 1. It's a null set. Say x such that x square plus 4 equals 0. X is a natural number. Can any natural number satisfy this equation? If x square plus 4 is 0, then x square will be negative 4. How can the square of a number be negative? So will I ever get a solution for this equation? No. So it is going to be an empty set. Understood? Guys, understood?
Yes, ma'am. Yes, ma'am.
Second, singleton set. A set with one single element. Any number, anything that is written within the bracket, only one number, only one element, that becomes a singleton set. No matter what is written, it is a singleton set. For example, singleton 1, singleton 0, even singleton 5. Within your curly bracket, what is written? Only one thing. What is that? 5. There is only one element. So that is known as a singleton set. Yes? No. Anything that is written within a curly bracket is an element. So within the curly bracket, I have written an element. So it can't be null set. There how many elements? 1. So it's a singleton set. Finite set. A set in which the counting of elements come to an end. Example, natural numbers smaller than 100. So there are 99 numbers. The counting is ended. X such that X is a letter of English alphabet. It's a finite set. There are 26. Yes, infinite set. Infinite set. A set in which the counting of elements will never come to an end. For example, all special sets, natural numbers, whole numbers, integers, rational, real. One more word I haven't taught till now, but intervals. I'll explain. Any doubt till here? Alright, any doubt till here?
No, ma'am. No, ma'am.
Since I'm ending with the note of counting the element, so we'll go to a concept known as cardinality or cardinal number of a set. Since we are talking about counting the element, so in infinite set the counting is not going to end. So I'm not even talking about that set. I'm talking about finite set where the counting will end. If the counting is going to end, you will end up with a number now. So a natural number smaller than 100. What is the count? 99. So you came up with an answer that there are these many people, there are these many elements in the set. This counting is known as cardinality. Cardinality of a set or cardinal number of a set denotes how many elements are present within your set. It denotes how many elements are present within your set. Yes. So cardinal number, it is denoted by n of a. This means number of elements in set A. Number of elements in set A. For example, what will be the cardinality of null set? How many elements are there in a null set?
0.
Zero. No element. What is the cardinality of a singleton set?
1.
1. Understood?
Yes, ma'am. Yes,
Yeah.
ma'am.
Now, if there are sets where the cardinality is same. For example, all singleton sets are going to have cardinality 1. Yes. Are the sets going to be equal? No. Are the elements inside are equal? Not necessarily. Singleton 1, singleton 2, singleton 3. All of these sets have their cardinality 1. But are the elements within the set also same? No. So such sets whose cardinalities are same are known as equivalent sets. Sets where the number of elements present is same is known as equivalent set. And in addition to that, if the elements are also same, it will become equal. Yes. For example, if I say, just an example, I'll write singleton 1, singleton 2. Are they equal? No. But their cardinality is same, the one element each. So they are equivalent. So we write this symbol. Now AB and BA. Number of elements, both of the case 2. Yes, they are equivalent. Are they equal also? Yes. The elements are same. The only thing that is changing is order, and set is not bothered with the order. In a set, the order of the element does not matter. So whether I write A comma B or I write B comma A, it won't matter. So yes, the cardinality is same, they are equivalent. And in addition to that, the elements are also same, irrelevant of the order. So they are also known as equal sets. Understood? So equivalent sets. Equivalent sets. Two sets A and B are said to be equivalent if number of elements in A is same as number of elements in B, denoted by A equivalent B. A equivalent B. For example, if I have a set A 1, 2, set B 3, 4, set C A, B, C. Cardinality of A is cardinality of A is
it 2?
2. Number of elements are 2. Cardinality of B
2.
2. Cardinality of C 3.
3.
So the sets which has the same cardinality are known as equivalent set. So since cardinality of A is same as cardinality of B, therefore A is equivalent to B. Equal sets. Two sets A and B are said to be equal if cardinality of A is same as cardinality of B and the elements are also same irrespective of order. Example, set A 1, 2, set B 2, 1, set C A, B. Cardinality of A 2, cardinality of B is 2 and cardinality of C is again 2. All the three sets have two elements within them. So all the three sets are equivalent to each other. Yes or no?
Yes,
Yes, ma'am.
Are equivalent
Yes.
to each other. But are all of them equal? Are all of them equal? Are all of them equal?
No, ma'am.
No. Which are the two sets that are equal?
A and B.
A equal.
And B.
Done?
Yes, ma'am.
Done? Any doubts still?
Yes.
Now, I use the word interval in between. Now, what are those? So, we'll go back to roster and set builder method again. When we talked about set builder to roster, I'll give you a condition and you need to write each and every element that is present within the set one by one. That is what roster method is. Question: x such that x is an integer and minus 3 smaller than x smaller than plus 3. So this is set builder. I have written the condition. What is x? X should be an integer and the value of x should be between minus 3 and 3. So I want to list down all the integers between minus 3 and plus 3. So if I want to write down in roster, what will I do? I'll list down all the elements. What are those? What are the elements?
-2, -1, 0,
1 and 2.
and 2.
Yes?
Yes, ma'am.
Okay. Now, if I would have written x such that x is a real number, x greater than equal to 2, less than equal to 4. Now, can I list down? After 2, first number will be 2, no problem. Last is 4, no problem. What is the real number just after 2? How can it be 3? 2.1, 2.2, 2.3. What is the number just after 2? If I say 2.1, you may contradict that no, 2.01. If I say 2.01, you can again contradict me and say 2.001. That's never ending. I can always add a 0 to it and give you a number even smaller than that. So I won't even reach 2.1. Forget 4. So if in a set builder they tell you x is a real number, or even if I would not have mentioned anything, if I don't mention anything also, it means it's a real number. In such a scenario, we can't write roster method. It's not possible for us to list down the elements in a serial order. So what do we do? In such scenarios, we take the help of intervals. Intervals helps us to write real number situation with the help of intervals without going into roster method. So question topic is intervals. Now there are three brackets. We have already used the curly bracket for a set. There are two more brackets remaining which you are supposed to use in interval. Whenever you have an equality, we will use the square bracket. Whenever we don't have an equality, we will use a round bracket. And remember, interval is only used for real numbers. It is only used for real numbers. You don't use it for anything else. First, x, suppose x such that and something something. 2 smaller than equal x smaller than equal 3. When we write interval, we use two numbers a and b. Always a will be smaller than b. Yes. So intervals can be a comma b. Start from a, finish till b. Yes. If you want to also take the number a, till now what I have written a comma b means take every real number between a and b. If you also want to take a, you will write a square bracket. If you also want to take b, you will write a square bracket. If you don't want to take any of them, another interval, a comma b, open interval. You are taking only the elements from between a and b. You are not taking a, you are not taking b. You are only taking whatever is there in between them. Yes. Then a square bracket, b round bracket. Between all the numbers I'm also taking a, but I'm not taking b. Wherever I write a square bracket, I'm taking that number. If I'm writing a round bracket, I'm not taking that number. Then a comma b. So in this case, I have to start from 2 I'll end up till 3. So I have to take all the elements between 2 and 3. Do I want to take 2? There's an equality in 2. So I'll take a square bracket here. Is there an equality in 3? Do I want to take 3? This line is equality. I also want to take 3. So I'll write a square bracket. This interval is known as closed interval. If I write 2 smaller than x smaller than 3, again I want to take all the elements from 2 till 3. Do I want to take 2? Do I want to take 2?
No, ma'am.
No,
So
ma'am.
round bracket. Do I want to take 3? Is there an equality in 3? No.
No, ma'am.
Round. If it is 2 smaller than equal x smaller than 3, again 2 comma 3, what should I write as the bracket?
In front of the square bracket.
Square and then round.
Square and
So 2 smaller than x smaller than equal to 3. Again 2,
2
3.
open bracket, 3 square bracket.
Very good. Done. Now this is open interval. We don't really need the name. Only I'm writing closed interval, open interval because in some of the questions you see this word. So I don't want you to get confused. Okay, what is this now? So just for that, we don't use it. For the sake of it, half, semi, half, open, half, closed. First bracket is square, that is a closed bracket. Semi, closed, open interval. This will be semi, open, close, interval. The last two names are not important. Sorry. Fifth. Okay. Now, before moving to more varieties, if I want to plot them in number line, say this is 2 and this is 3. I want to write 2 comma 3 this. So I want to take all the elements from 2 till 3. Do I want to take 2? No. Do I want to take 3? So the number that I want to take, I will fill the circle. The number that I don't want to take, I'll have an empty circle. Can you see that? Yes. And I want to take every element in between. So either I highlight it or you can also give a bracket in this way. Yes. If I would have had 2, 3. So number line starts from minus infinity, goes till plus infinity, 2 and 3. All the numbers between 2 and 3, what should be the circle? Guys, 2 will be filled circle because it's equality. 3 will be an empty circle. I don't want to take. Clear?
yes, ma'am.
Continuing. 5. X smaller than equal to 3. So this is 3. This is minus infinity. This is plus infinity. X should be smaller than 3. So I want to take the region on the left of 3. So this is the region I'm talking about, right? So this will be from minus infinity till 3. In 3 I have an equality. So I'll take square. In infinity, both plus and minus, I can never have an equality. Why do we write equality? I want to take 3. Infinity is not a location you can take. So in infinity and minus infinity, irrespective of the question, it is always a round bracket. Yes. If I write x smaller than 3, wherever the mouth opens, it's the larger number. Wherever there is a pinpointed V, it's a smaller. So x is smaller than 3. So x is on the left side of 3. So same, the only difference is open interval. If I say x more than minus 2, so right side of minus 2, what should I write? What should I write? What should I write?
Mm,
First minus 2, then infinity. No
in-
equality, both will be open. Yes?
Yes, ma'am.
If I write x more than equal to minus 2, again same region, minus 2 to infinity. I'm allowed to take minus 2, I'm not allowed to take infinity. Any doubt? Online, any doubt?
No, ma'am.
No, ma'am.
No, ma'am.
Any doubt? Now we'll move on
No.
to a new topic, that is subset. One of the very important topics. Now, what do
Ma'am.
we... So, subset. Subset is just a fancy name for a part. So, for example, the entire cake. The entire cake is a set. The pieces that you are allowed to eat is a subset. So, I can have a one slice. I can have half of the slice. If I want to eat, I can eat the full cake also. Right? So, full cake is your set. The portion that you get to eat, the part of the cake is known as a subset. So, for example, if I have a set A, 1, 2, 3, and I take another set A, set B, which shops its element from the set A. So, set A has how many elements? 3. What are the 3 elements? 1, 2, and 3. So, if I take sum of the elements, say B is 1, or I take another set C, 1, 2, or I take another set D, 3, 2, 1, or if I take another set E, that is 4, right? So, out of these sets, if I talk about these sets, right? If you see the elements that are present within the set B, which is 1, is also present inside the set A. All the elements of the set B are present within the set A, right? So, B is a part of A. Agree? B is a subset of A. B is a subset of A. Again, all the elements of set B are also present in C. So, B will also be a subset of C. What else? So, B has 1. Is that one present inside C? Yes, so B is a part, na? If I eat half the cake, you say half is left. That's okay. I have eaten a portion of it, na? I'm okay with it. I can take the entire cake also, I can take a portion of it also. Right? Again, B is also a subset of B is also a subset of
D.
D, right?
Yes, ma'am.
Because 1 belongs to A, 1 belongs to C, 1 belongs to D. The only element present inside B is 1, and that element is also present in A, C and D. So, B is a subset of all the three. Again, C has how many elements? 2, 1, 2, and those two elements are present in both A and D. Agree? So, C is a subset of A, C is a subset of D. Can I say that C is a subset of D? Can I say that C is a subset of B?
No, ma'am.
No. Why?
Because in C there is 1
Two
and 2.
elements, 1 and 2.
Yeah, two
1 is there
elements.
in B, but 2 is not there. So, when I'm saying no, I should have such a pinpointed example. No, it is not a subset. Why? As 2 is present in C, but 2 is not present in B. Yes. Now, if I talk about A, can I say that A is a subset of B? A has 3 elements 1, 2, 3. Those 3 elements are also present in D. Reverse. Can I say that D is a subset of A? D has 3 elements 1, 2, 3. Those are also present in A. So D is a subset of A. And since they two are subsets of each other, I can conclude that A is equal to B. A less than equal to B. B is also lesser than equal to A. That means they are equal. So A is a part of D. D is a part of A. That means they are same. Agree? So what do we mean by subset? A set A is said to be a subset of B if all the elements of A are also present in B, denoted by A subset B. Understood?
Yes,
Now,
ma'am.
if you see all these three examples, yes, B is a part of A, but it is a smaller part. Is it equal? Is it the whole cake? No. B is a subset of A, and I'm guaranteed sure that B is not equal to A. B is not equal to C. B is not equal to D. Agree? So it is a part, but it is not equal. So in subset, the line that I'm writing in the bottom, that says that they may or may not be equal. I'm not sure. But in BA, BC, BD, I'm 100% sure I can see that B and A are not equal. Yes, it is a part. Yes, it is a subset, but they are not equal. Again, I can see that B is not equal to C. I'm sure that B is not equal to D. So even if I want to, I can do what? I can remove this equality symbol, right? Even then it will be okay. When I write this equality, what do I mean? May or may not be. I'm not sure. Either it is equal, it may not be equal. Safer side, I just write it. But when I'm 100% sure that they are not equal, then what will I write? I'll remove the equality sign. When I remove the equality sign, this symbol is known as proper subset. So when I say subset, the two sets may or may not be equal. But when I say proper subset, I'm giving you another information that I'm 100% sure that the two sets are not equal. So proper subset is just one extra limit. Yeah, it is a subset, but it is 100% smaller. It is 100% unequal. Then it is known as a proper subset. Can I do that for A and D? Can I write A is a proper subset of D? No. Why? They are equal. If I remove the below equality sign, and that means I'm telling you they are not equal, which is wrong. I have to write here equality. Here I can't remove. That's why for a safer side, we usually write equality everywhere. But if they ask me which one is correct, this one or this one, I'll write proper subset is a better answer. I have to take that because it gives you a better information and extended information. Yes, it is a subset, but it is a smaller subset. It is not an equal subset. That's why it's proper. Understood? So when I say proper subset, a subset A of B is said to be a proper subset if A is not equal to unequal subsets. Unequal subsets are called proper subsets. Unequal subsets are called proper subsets. Understood? Example. Suppose I take a set A, 1. Okay, note first before this. Can I say that A is a subset of A? Obviously, right? So every set is a subset of itself. That is, A is a subset of A. Always. If I say that no, just say here we said that C is not a subset of B. You said no. And you backed it up with an example. See, there is an element in the set C2 which is not there in B. So it is not a subset. I was okay. Yes. So now think and tell me, can I write null set is a subset of A? So is null set a subset? Say A is 1, 2. Will null set be a subset of A? Why? Why? See, if I want to say a subset, the definition says A is a subset of B if all the elements of A are in B. How do you say A is not a subset of B? If there is an element in A which is not present in B. So whenever you want to say no, you need to have an example. You should have a reason. Ask your parents for a reason, for a trip permission, and they say yes. Do you ever ask a reason why are you saying yes? No, definitely no. But if they say no, you'll definitely assume all my friends are going, I'm mature, I'm responsible. You'll give them n reason. So until and unless they give you a pinpointed reason, even then you won't agree. But still, they have to give you a reason. They are taking you somewhere else. It is clashing with something else. Your exams are nearing. They'll give you a pinpointed reason so that you shut up. Agree? Similarly in maths also. If you want to say no, no, it is not a subset. You need to give me a reason, not a reason, an example. Like here you gave me. C is not a subset of B. Why? C had 2, B did not have 2. I accept it. In this case, null set is a subset of A. If you tell me yes, I may not ask you. But if you tell me no, I need to know. So if you say no, null set is not a subset of A. Can you give an example of an element which is there in the null set but it is not there in A? For no, you need to give me an example, na? That null set has this element but it is not present in A. That's why it is not a subset. It does not have an element. How will you give an example? Since you can't back it up with an example, if you tell your parent, why? Just essay. Will you accept? No. You'll say, then what? Then I'll go. You'll become a rebel. Similarly here, become a rebel. If you can't give me a reason, a pinpointed example, an explanation for no, तो आपका चुप्पी में आपका हाँ. If you don't give me a no, it is going to be by default yes. Will you ask the reason for yes? No. So here also don't ask. Can you tell me a no reason? No. So by default, it becomes a yes. So whenever you can't back your no with an example, by default, it becomes a yes. So here, since null set does not have an element, so you can't give an example, see, there was one in null set and that one is not present in A, so it is not a subset. So since we can't give an example, that's why by default, it becomes a subset. You haven't eaten anything. It's okay. It's still a part of the cake. Have you done something that is out of the party's rule? No. You eat something that wasn't there in the party. That's wrong. Right? You can't bring outside food. Agree? But you can definitely go without eating. That's okay. You go to a party. Can you bring your own food to that? No. So outside members not allowed. But if you don't eat anything there, is that allowed? Yes. To go to a party, you come back without eating anything. You are not well, you are having a fast, any number of reasons, you don't like the food. So you can come back without eating. Similarly, do you have an example? Do you have anything present in the null set for an example? No. So by default, it becomes a yes. बोलो नो बोलने के लिए एग्जाम्पल देना पड़ता. आप मेरे को बोल रहे हो सी इज नॉट अ सबसेट ऑफ बी. बोला क्यों? देखो सी में 1 था ना, पर बी में नहीं. 1 2. हाँ, वो कुछ नहीं खाया. इट इज नॉट अगेंस्ट द पार्टी रूल. It's okay. You're okay. You're still in order. For yes, it is not necessary for you to satisfy the definition. But for no, you need to go against the rule. You're sitting in the class. You may have done your homework. You may not have done your homework. But if I'm throwing you out of the class, won't you ask me a reason why did you throw me out? So if you are saying no, you need to give a reason. If you are saying yes, it's okay. Understood? So null set is a subset of every set. And here, if I remove this and I write this, will that be okay? Obviously, your set is not a null set. There is an element inside your set. So I can remove the equality. If there is an element in A, I'm 100% sure that null set and A are not equal. So I can remove the equality set. So every subset except null set will always have two subsets. Khud, the set itself, and for example, set A, 1, 2. What is the cardinality of A? 2. What are the elements? 1 belongs to A, 2 belongs to A. When I write the subset, null set will come, set A will come. What I want to take are bits and pieces of the set. So what can I take? I can take 1, make it a set. So this set singleton 1 is a part of the bigger set A. So yes, it is a subset. Again take another element of A, singleton 2. Again it will be a subset. Take both of them 1, 2. But I won't repeat. A itself is 1, 2. I've already written that. 1, 2 or 2, 1. How does it matter? So these are the only 4 subsets. So number of subsets 4, 2 square. If I have a set B, 3. What is the cardinality of B? 1. What is the element? 3. So if I want to write the subset, null set B itself, will there be anyone else? No. So number of subsets 2, 2 power 1. If I have a set C, A, B, C, what is the cardinality of C? P. A belongs to C, B belongs to C, C belongs to C. Say P. Done? Subsets. What will be the subset? Null set P, singleton A, singleton B, singleton C, AB, BC, CA. I won't write ABC again because P itself is ABC. So number of subsets 8, 2 to the power 3. So why did I write this? To give you a formula at the end. What? If number of element in the set is 2, number of subset is 2 power 2. If number of element in the set is 1, number of subset 2 power 1. If number of element in the set 3, number of subsets 2 power 3. If the set will have 4 elements, how many subsets? 2 to the power 4. If a set will have 5 elements, how many subsets? 2 to the power 5. If a set
5.
has n elements, how many subsets? 2 to the power n. That is your formula. Number of subsets of A. 2 to the power cardinality. Yes or no? The number of elements present goes to the power. Now if you see, except P, all are proper subsets, all are smaller. Here, except B, all are proper. Except A, all are proper. So except 1, the set itself, all the other subsets are what? Proper. So out of here, how many proper subsets will be there? Everything except 1. Remove the set itself. For example, if the cardinality of a set is 5, how many subsets will it have?
2 power 5.
2 power 5, 32.
Yes, ma'am.
How many proper subsets will it have?
2 power 16.
No? Why 2 power
Oh,
16?
31 months. Sorry.
Everyone except 1. 31. Remove 1. Understood?
Yes, ma'am.
Done? So if a set has 7 elements, how many subsets? 2 to the power 7, 128. How many proper subsets? 127. Understood? Question. If I have a set B, the elements are 0 and 1. Write down all the subsets. How many will it have? 2 to the power 2, 4 subsets. So write down all the 4 subsets. Null set B, singleton 0, singleton 1. You basically first write the elements inside the set B and then just put them in bracket. They become subset. So 0 belongs to B, but singleton 0 is a subset of B. Understood? Anna. Question 1, 0. How many elements are in C? 2. What are the elements? 0 belongs to C and this as a whole belongs to C. In whichever shape and form the element is present, you take it as it is. No partiality. How many elements? 2. How many subsets? 2 to the power 2, 4. Write down. Null set C, singleton 0. The element put in the bracket becomes a subset. So now singleton 1 was an element. If I want to make this a subset, what will I do? Put it in the bracket. No partiality. If I have a set D, null set A comma B. How many elements? From 2. There are only 2 elements. First, phi is an element of D and this as a whole structure is an element in D. You can break it down. How many subsets? 2 power 2, 4. First, null set, the set itself. Now, the elements that are present in D, just keep on writing them in the bracket. Okay? So, this was an element, put it in the bracket. This was an element, put it in a bracket. जो भी एलिमेंट होगा बस उसको ब्रैकेट में वो सबसेट बनता है. तो अगर ऐसा है that P is an element of B, then you put it in a bracket, it becomes a subset. This is an element in C. Okay, that means as a whole it is present inside the set C. If I want to make it into a subset, I'll put another bracket. It will become a subset. For example, wait, set A has 1, 0, 5. How many elements? 3. Let's list down all the subsets. How many will be there? So if I want to write down all the subsets, there will be 8 subsets. First, list down the subsets. 5, singleton 1, singleton 5, 1 comma 0, 0 comma 5, 1 comma 5. This is what? List of all the subsets. Understand first, I'm teaching something new. I have listed down all the subsets. So this is a collection of all the subsets of it. Now, if I put this in a curly bracket, what will this become? A set. Anything that you put in a curly bracket becomes a set. What type of a set is it? It is set of all subsets of A. Yes or no? This is known as power set. Power set. The set of all subsets of a set A is known as power set, denoted by P of A. So how many elements are going to be present inside the power set? Number of subsets. So how many subsets did it have? 8. How many elements will be there in the power set? 8. So number of elements in the power set is same as the number of subsets. Hana. So if formula, if number of elements in A is m, then how many elements will its power set have? 2 to the power m, same as the number of subsets, same as number of subsets. Did you understand? जितना सबसेट्स है उन्हीं सबको हम लोग सेट में डाल देता है तो सबसेट बनता है. तो अगर एक सेट में 4 एलिमेंट है, कितने सबसेट होंगे? 2 पावर 4 16. 16 का 16 पावर सेट में चला जाएगा, तो पावर सेट में कितने लोग होंगे? 16. So if a set has 5 elements, how many subsets will it have? 2 to the power 5, 32. Those 32 will go inside the power set and become its element. So power set will have how many elements? 32. Same as the number of subsets. Understood? Everyone? Clear? So subset, if it is a part of the set. If every element of the set A is a part of B, then it is known as subset. If it is 100% unequal, it becomes power set, proper set. So if a set has 6 elements, how many subsets will it have? 2 to the power 6, 64. How many proper subsets will it have? 63, one less. How many elements will be there in the power set? 64. Same as the number of subsets. Understood? Clear? That's it for today.